During a game of golf, Kylie and Cassandra hit their individual balls out of a sand trap. The height of the ball can be modeled by the equation for each individual player. X is in terms of times of seconds since the ball was hit. So here's my bad illustration for those that have not golfed or watched golf. So here's a sand trap down here, and so they hit a previous shot and they end up in the sand trap, which is lower than the level. So they're below the level here, and I can see that by the y-intercepts in standard form. And they're going to take this ball and using their clubs, they're going to hit it out to try to reach it up here. So the projection of the ball, if done right, they're going to swing upwards and the ball is going to go something like this. That's why we have a parabola that's opening up downward. Part A says, whose ball went higher? So I input both Kylie and Cassandra's equations that models the pathway of the ball. And for mine, it's going to be easier because I can see blue is the first one. So blue is Kylie and red is Cassandra. I know you don't have that advantage with your calculator, but we'll be able to see based on the y-intercept to differentiate between the two. Okay, and whose went higher? The blue went higher. Blue went higher, so blue represents Kylie. Again, for you, if you're looking over here, you can go second graph and you'll be able to see, okay, which one is the Kylie and which one represents Cassandra. Second question is, whose shot hits the ground the fastest? Remember, X is in terms of the time the ball is in the air, and then this is the height. Y is the height of the ball. So I can see that if this is the ground, that the red hits first. Red is Cassandra. The third part C says find the rate of change of Kylie's ball over this interval. Kylie is blue. I'm going to get rid of red to ensure that I don't have any extra confusion. These represent two X values, so they want to know from the time the ball hits the air to 0.5 seconds, how fast in this case is it rising. So I know that I go second trace value, 0 corresponds to -4. Second trace value, 0.5 corresponds to 4.5. Rate of change is the slope. How fast is it rising or falling over this period of time? I'll label the numerical values with x1, y1 for the first order pair and x2, y2. Plug those values into this equation, and you can do mental math or grab a calculator. So 4.5 subtract a -4. Remember, two negatives make a positive, and if you don't feel as comfortable, then use your calculator. 4.5 subtract a -4, you're going to end up with 8.5 on top. 0.5 subtract nothing is 0.5. And now use that calculator to go ahead and go 8.5 divided by 0.5 is 17. So the answer is 17, but what does this mean? You need to be really specific when answering this. What does the rate of change mean? It means for this problem, over the first 0.5 seconds, so from when the ball was hit in the sand to would have been in the air for 0.5 seconds, the ball was rising at a rate of 17 feet per second. Part E of problem number 12. At what moment or moments is Kylie's ball 4 feet in the air? Well, I'm going to zoom in on this real quick so I can see a little better. I want to take and go, I don't need all those negatives. Let's go from -5 to positive, and let's go -5 up to 10. Just see if that's a better way to look at this. We can even zoom in a little bit more. I don't need to go up to 10. Okay, great. So if I went straight across here at y equals 4, I can see there's two places in which the ball is 4 feet above the ground. When it's going up, then it hits its peak height, and when it's coming down. So I'm going to have two different answers. Now we could do this algebraically, but I believe the fastest way, when you have a calculator available, is to go to y equals 4 and graph it. Where they intersect is the two different answers I want to know. Remember, the question says at what moment. So they're talking about time. time is your x value, and y is the height above ground, in this case 4. Second trace, intersect. Left bound, right bound, and center. This means the ball, and it says here to round your answer to the nearest hundredth. So 0.45 seconds is one answer when it's 4 feet above the ground. Second trace, intersect. Second, there we go. And at 1.2 seconds. In both of these cases, the ball would be 4 feet above the ground.